All right, fourth graders, here we go. We are going to shove two lessons into one assignment. So bear with me. I know Mrs. Pettis says you have done this before. There's a lot of vocabulary and drawings in this one, so I'm going to encourage a sheet of the white graph or grid paper at the front of the room. Just one sheet should do, maybe two. We're going to talk about translations on a coordinate plane, and we're going to talk about, don't worry, the finger dance is coming. We're going to talk about the coordinate plane. First of all, I'm going to point out some things. You can pause it and just make the actual T with the little arrows, which indicate it goes on and on for infinity. So you can notice here that we now have a -1, -2, -3, -4. A lot of times we just dealt with things that were in the positive or the quadrant 1. We also have a negative that goes down, 1, -1, -2, -3, -4, and so on. You'll be using this type of a coordinate plane all through your math career, and especially in Algebra 2 and probably trigonometry. So this is not going away. This whole dealio is called the coordinate plane, and I want you to memorize where the quadrants are. So we always start teaching kids in quadrant 1. That's the easiest. And then what it does is it makes a giant C. It goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. So they'll name a point on your assignment, say right here, or they'll give you the coordinates and say what quadrant does it belong in. And you need to be able to say quadrant 3. Okay, this is not hard. It just is, you got to memorize that it goes this way in a C. Quadrant 4, the Roman numerals is the 1 and the V. That's 1 less than 5. Or you can just say quadrant with the numeral 4. The x-axis is the one that lays flat, and the y goes up and down. Okay, so make sure that if you do have a point and it asks what quadrant it lands in, and it's on like this point right here, you would say it really isn't in a quadrant, it's on the x-axis. Or if it's up here or down here on that y-axis, you would say it is on the y-axis. It is not in a quadrant, it is on the axis. Okay, so we are going to practice the finger dance. And the finger dance is over and up and over and up and over and up. I know that might be kind of weird, but the more you do this, you will remember your motion of going over and up. So you always list coordinate pairs, whether you're here or in Antarctica as a mathematician, in terms of x then y. It's alphabetical. And x is always over, and y is always up, okay? So I drew a new coordinate plane right here, and we are going to graph point A at -2, 0. So we will go -2 over, which would be 1, 2, and 0 up. So I would make this point A. For B, we go 4 over. That's 1, 2, 3, 4, and then we go -2 down, 1, 2. So that would be B. If you want to pause me and see if you get them in the right spot, that's fine. Or if you think you need to watch me do it, you can keep the video running. So 0 over and -3 would be no over, but that would go down 1, 2, 3. This is falling on the y-axis. That's C. Now we have D is -2, -1. So -2, -1, that's D. And that's falling in quadrant number 3. And E, -1, and then 2 up. That's in quadrant number 2. That's E. And then 1 over and -4. 1, 2, 3, 4. That's F. So notice I don't have any in quadrant 1. Those are really easy. So if I had 3, 4, and we were going to name that G, that would be 1, 2, 3, 1, 2, 3, 4. And that would be my point G. And that's in quadrant 1. It'll be helpful for you to refer back to especially this. This describes everything we're going to be doing. So what we are going to do for a translation is when a figure slides across the coordinate plane, up, down, or whatever, it looks identical to its original one. It's just scooched. So the formal definition you can write down, it's when a figure on a coordinate plane slides the same distance in the same direction. Then the new figure is the image or replica of the original. So what I'm going to do is I'm actually going to take a little post-it note and I'm going to make a triangle out of it. So let's say that the triangle is up here. A translation would be just scooching it the same way down here, the same way here, the same way here. There's no rotating or flipping, it's just sliding. Okay? I should have made them smaller, but that's okay. So we're going to try this one. We're going to try to connect the points for a triangle ABC and then translate it 3 units to the left and 2 units down to form a new triangle called DEF. So we're going to give the coordinates for the new vertices. So what we do is they gave us the first triangle. So we need to do that. So -4 over 1, 2, 3, 4, and 1 up. That is A. B is -1, comma, -1. That's B. C is 2 over 1, 2 over, and 1 up. Okay, so then we would connect the dots. And I'm going to use a different color so that you can see where it goes. I'm going to use purple because I just like purple. So it says that we want to move it 3 units to the left and then 2 units down. So I'm going to take A and I'm going to go 1, 2, 3, and I'm going to go down 2. 1, 2. He lands right there. So that would be D. Oops, I forgot to label him. And then we are going to go to the next one, which is going to be E, because it's the middle component. And we're going to do 3 units to the left and 2 units down. Ready? 1, 2, 3, 1, 2. And now we are going to do the corresponding one, which would be F. And we're going to go 3 units down, 1, 2, 3, and 2 units to the left, 1, 2. Did I do that right? 1, 2, 3, 1, 2. Oh, wait. Sorry. 3 units to the left and then, sorry. 1, 1, 2, 3, 1, 2. I didn't think that looked right. So it's landing in the same spot as B, and this is F. This is an oopsie, easy to do. That's why I use my colors so I can see what I'm doing. Colored pencils work if you have erasable ones. So when you look at this, can you see that this triangle just slid and went down? That's a translation. Okay, so then what you would do is you would have to write the ordered pairs for this. So this F, I'm going to start with that because it's closest to the origin, which is the middle right here. I put that at the top. It's the origin. It's not in a quadrant. And that is -1, comma, -1. And then we're going to do E. And that is 1, 2, 3, 4. So -4, comma, 1, 2, 3, -3. 1, 2, 3, 4. Yep, I did it right. Sorry, I second guessed myself. And then we're going to do D. So it's all the way over here, which is 1, 2, 3, 4, 5, 6, 7. It's a -7, comma, -1. So for me, I'm really visual and I really do like to see the drawings. I do like the colors. Some of you can just sketch these out. You can see it in your brain a little bit better and you can figure that out with no problem. So I want to show you some of the things that you're going to see in the book, and don't hesitate to use pages 603 and 604 to see how it works. And we're using those positive and negative integers, adding and subtracting. So when you're moving something, you have a rule of a plus 4 minus 5 if you are moving like this parallelogram down to here. If you just follow the plus 4 minus 5 for all of the points, it ends up sitting in the right spot. It really isn't hard, except it looks like a mess when you get to these questions. I just want to point those out. Graph the points to form ABC and then move 3 to the left, 2 units down, and they give you a whole bunch of different points, and then the new points are down below. Well, it's sometimes hard for kids to see that without actually drawing the picture. So I'm going to encourage you today to kill that tree and make those images and those pictures, all right? It should be a rather straightforward lesson. Use the terms in the book, use your notes, but it's one that students usually do enjoy because it's drawing things. Have a great lesson.